So, hello students. In this session, we look at a few examples related to your revision program for UT, okay, grade 8 maths. So, let's start off with the first topic, that is properties of rational numbers. So let's talk about property. When I talk about property, we know this property of commutative property of multiplication and addition. See, commutative property. What is commutative property? It holds good only for addition and multiplication of rational numbers. So if I give you two rational numbers, let's say a by b and c by d. So if I add them, if I add a by b with c by d, it's going to be the same as c by d plus a by b. So this is commutative property of addition. This is for addition. Likewise, I'm talking about multiplication. I will have a by b into c by d. The product will be the same. I mean, when I multiply, I say the result is called product. When I add two things, we say it is summation or summing. So it is as good as c by d into a by b. So it's going to be the same. Now remember, associative property will hold good for addition. Commutative property will hold good for addition and multiplication, not for subtraction and division. Likewise, associative property. So what is associative property? I'm going to take three rational numbers. Let's say a by b, c by d, e over f. So I'm going to add them. The order wouldn't matter. As in, I can add the first two, the first and the second. And to that sum, I can add the third rational number. I would get the same answer if I'm going to add the second and the third. Okay. And then I'm adding second and third. And then I'm going to add that result to the first. See, I'm going to get the same answer. That is in the case of addition. Okay, addition of rational numbers. So the order doesn't matter. So when I put brackets, that means that particular operation I'm going to perform first. We have seen this earlier also in the case of integers, whole numbers. So even for rational numbers, addition is associative. The same thing holds good for multiplication. A by b into c by d into e by f. So it wouldn't matter if I multiply the first two and then multiply that product with the third. I would get the same result if I'm going to multiply the second and the third rational numbers and then multiply it with the first one. Okay, so keep in mind that associative property will hold good for multiplication and addition, not for subtraction and division. The same thing with your commutative property as well. Okay, then you need to know what is the additive identity. Now, right, for whole numbers, for integers, and then even for rational numbers, the additive identity is 0. So whenever I add any rational number to 0, I'm going to get back the original rational number. Whichever way I add 0 plus 2 by 3 or 2 by 3 plus 0, I'm going to get back the original number. 0 acts like a mirror in addition. And in multiplication, it is 1. We have discussed this. So the multiplicative identity will be what? 1. Let's say minus 3 over 13 into 1. I'll get the same number back, regardless of the order in which I multiply. I'm going to, okay, let me just erase this. Okay, minus 3 over 13. I'm still going to get back the original number, isn't it? So 1 acts like a mirror in multiplication. Now, with this in mind, we need to understand the concept of additive inverse. See, if I take the number, let's say 7 over 13, its additive inverse is minus 7 over 13. Upside down. See, sign has changed. And its multiplicative inverse means reciprocal, that is 13 over 7. So what's happening here? In additive inverse, I'm not swapping the numerator and denominator position. I'm just changing the positive sign to negative sign. Suppose I have minus 5 by 12. So its additive inverse will be plus 5 by 12 or simply 5 by 12 I can get. If I don't mention anything, it's understood to be plus. And what is the multiplicative inverse of minus 5 by 12? Multiplicative inverse means reciprocal, right? The 12 will go up and the minus 5 will come down. Or in the standard form, minus 12 over 5. In the standard form, we always keep the denominator positive. So this you need to keep in mind. And then if I give you a number like 3, its additive inverse will be minus 3. What is the multiplicative inverse of 3? Yeah, for 3, in rational terminology, rational numbers, we write it as 3 by 1. And its multiplicative inverse will be 1 minus 3. Okay, so with this, you also need to remember that the additive inverse of 1 will be minus 1. Additive inverse of minus 1 will be plus 1. What about the multiplicative inverses? Multiplicative inverse of 1 is 1 itself. And multiplicative inverse of minus 1 is minus 1 itself. So this you need to remember. What about 0? 0, its additive inverse is defined. Additive inverse of 0 is 0. And there's nothing like negative 0. There's no negative or positive 0. 0 is neutral. But then 0 doesn't have a multiplicative inverse because what is the multiplicative inverse? It should be 1 over 0 and it's not defined. In maths, division by 0 is not allowed. So this you need to keep in mind. So you need to know the concept of multiplicative inverse, additive inverse while solving problems. We have discussed all this in class under properties. Let's move on to what happens when we multiply a number with its additive inverse or multiplicative inverse. So let's take the example 3 over, let's say 7. Okay, its multiplicative inverse is 7 over 3. So 3 over 7, let me multiply it with the multiplicative inverse. What do I get? 7 ones are, 7 ones are, 3 ones are, 3 ones are. It's going to cancel 1 over 1, which is 1. So the product of any number with its multiplicative inverse is 1. So you need to remember. And the property is not that I will give you a straightforward sum. I might ask you in terms of fill in the blanks or MCQs. In MCQs, even if you do any amount of working, the final answer will be considered. Okay, the working is not, you will not get partial answers for steps in MCQs. But in fill in the blanks and subjectives, you will get steps for the partial step marks for the steps for the working. Now bear in mind that whenever we give you like this, how much ever you have worked out, in MCQs, the options are already given. That is why. Now, even if you go to higher grades, in the MCQ pattern, you will not be given marks for steps or for the working. Okay. That doesn't mean we'll be doing a guesswork. We'll be solving because the options sometimes will be confusing. For example, if I give you the multiplicative inverse of 3 by 7 is, I'll say minus 3 by 7, minus 3 over minus 7, 7 over 3, 7 over minus 3. So all of them look confusing because they all look similar. At the same time, they look confusing sometimes. Now, if your concept is strong, you will not have a chance for any confusion. There's no ambiguity here because there's only one answer which is correct. No multiple answers. You will have 4 choices. So multiplicative inverse of 3 by 4. Multiplicative inverse, or even I can word it as reciprocal. Sometimes I will be saying multiplicative inverse. Sometimes I will use the word reciprocal. They both are the same. So you need to know the concept. So when I take the multiplicative inverse of a number, the numerator and denominator positions are swapped. The sign is not changed. So 3 remains as 3, 7 remains as 7. The minus and plus happens only in the case of additive inverse, isn't it? So keeping this in mind, the answer will be C. Now, if the concept is not clear, you're likely going to get astray and go astray, and you can, easily get carried away, and you might think it's option A or maybe option D or something. So you need to be very clear. Okay. And you need to know that 0 has no reciprocal. 0 has no multiplicative inverse. All right. The other type of problem is I can give you 2 numbers. Let's say, okay, there are 2 rational numbers that add up to, let's say, 5. One of them is minus 2 over 3. Find the other. This is an English statement. Okay. So what do you need to find out? You need to find the other number. Two of the rational numbers. Do we know both? We don't know. The unknown number, let it be x. So you have to now, as I mentioned, you will not be writing long English statements. You need to show mathematical steps because you're going to get marks for steps and not for the English content that you write. If it's a law or a property, you can mention it. Like in indices chapter, I told you the laws are important. But here you can directly say one of them is minus 2 by 3. Yes. Do I know the other? I don't know. I have to find it out, isn't it? So let that other number be x or whatever variable. Now that you know a fair bit about algebra from last year, I thought I can use x. Okay. You can use y or you can use z. Very commonly we use x. So it's something like, whenever I think of algebra, I think of the variable x, something like that. So minus 2 by 3 plus x will add up to 5. I need to know what is x. My, what do you say, the aim of this, I need to find out the required answer is to find out what is x here. That is the thing here. So minus 2 by 3 plus x is 5. So what is x? X is the unknown. I need to find the value of x so that when I add x to that given rational number, I will get 5. So my aim is to find x now. So x is equal to, or simply I have x is associated with plus sign. Keep x plus x or simply x. Because when you put plus x or if you simply put x, it doesn't matter. So let's just erase it for now. By convention, understand that plus x means x. I'll just have to keep x one side. I have 5 on the right hand side. This minus 2 by 3 also I have to shift it to the right hand side. Because I want to find out x, I need to keep only x aside. So minus 2 by 3 goes to the other side, it becomes plus 2 by 3, 2 over 3. Now I have to add 5 with 2 by 3. So what I can do is, I can, and I told you that whenever you have an integer, we can convert it into a rational number. For example, minus 3. This is an integer. In the rational number terminology, it will be minus 3 over 1. Just put a 1 down because putting a 1 in the denominator position, it doesn't, it's redundant. So when I say minus 5 by 1, it is same as minus 5. Okay, so here it is 5. So write 5 as 5 by 1. Because we have 2 by 3, which is the rational number. I have to add them. So now we'll add them as like we do fractions or, this is familiar to you. The LCM of 1 and 3 is 3. Nothing big about it. So 1 will go 3 times. So 5 3s are 15. 3 will go 1 time. So 2 1s are 2. 17 over 3. Okay. So this is your standard form of the rational number. The other number which I need to find the other. That is the other number is 17 over 3. We can always cross check. It's not required for you. In the exam, you don't have to show it. It's not required. Just I'm telling you that how we can verify. What was the one of the rational numbers? It is minus 2 by 3. What is the other rational number? 17 by 3. When I add, what do I get? 3 is the common, the denominator is same. So I can say minus 2 plus 17. Minus 2 plus 17 is 15 over 3, which is 5 over 1, or simply 5. I'm getting back the. Okay, the verification step is not required. You just show 3 steps. You show the mathematical step saying that minus 2 by 3 plus x is 5. Then the next step is transposing, where you take the minus 2 by 3 over to the right hand side. The third part is simplification and reporting the answer as x is so and so. So even if you go wrong, this can come, this type of question. I'm not saying the same numbers. So whatever I'm discussing today, don't expect the same type of numbers, same number. The types will be more or less be the types that I've taught. I'm teaching you here and what we have done in classwork. But don't, get carried away. The same number. That's why I'm telling you that you need to know the methodology. If you know the method, it doesn't matter if I'm going to change the numbers. So you're going to do it the same way with different numbers. But the workflow or the working methodology you need to understand. Okay. All right. So that is important here. When you solve for x, how you solve for x. And then you take from left hand side to right hand side, the negative becomes positive or positive becomes negative. So these kind of problems you need to understand. Verification I've showed you here. Please do not waste time doing it in the test. because nobody will look for your verification. We just want you to report X. If you're a bit confused, or if you just have time to think that am I getting the right answer, is something wrong with X, for you to verify, this is the procedure where you do the verification in this way. It's not required for you to show it in the test. Okay. So you need to know what is the meaning of multiplicative inverse, what is additive inverse, what am I doing here? From left hand side, I'm taking it to the right hand side. Okay. Or what is the meaning of sum addition, right? I'm going to add two things. I'm going to sum up two things. If I same thing, if I said product, then things would be different, right? It's multiplication. And bear in mind the signs. Then suppose there's a question like minus 4 by 5. What is its additive inverse? Its additive inverse will be plus 4 by 5. See, just like when you multiply any number with its reciprocal, or I mean to say any number with its multiplicative inverse, what is the product? 1, isn't it? A by B, reciprocal of A by B is B by A. I'm going to get 1. The same way, when I add any number with its additive inverse, I'm going to get 0. That you need to know. So any number added to the additive inverse will give me 0. The sum of a rational number and the additive inverse is 0. The product of a rational number and its reciprocal is 1. Okay. Then another type of question is, we'll take something with product. Product of two rational numbers is, let's say, minus 21 over 5. Some random number I'm taking, okay? One of them, there are two numbers, so two numbers which I'm multiplying. One of them is 3 by 25. Find the other. Whenever there is a negative sign, also be careful. After multiplying, many times we forget the negative sign, and you need to know the laws, the rules governing this. Minus into minus is plus, plus into minus is minus, or minus into plus. It doesn't matter because multiplication is commutative, isn't it? Minus into plus will still give you minus, and plus into plus, of course, is plus. So sometimes be very careful when you're doing in a haste, in a hurry. You might tend to leave out these basic things, plus and minus. And even a small negative or positive you put in one step instead of the required sign, the whole sum can go wrong. Propagation of error. The first step is wrong, and naturally the second, third step will go wrong. So be very careful. So then, just for the method, we will not be able to give you marks for a 3-mark problem, because if the first step is wrong, then if the first step is right, but the last answer is final answer is wrong, still you will be getting some marks, partial marks for the steps. But you need to see that the first step is correct. So this is the English statement. Okay, the word problem. There are two rational numbers. I don't know the other one. No, one of them I know. So what is one of them? One of them is 3 over 25. One of them. Find the other. The other I don't know. I can call it as x or y or whatever, any variable I told you. So I'm going to get minus 21 over 5. So the same logic. See, whenever I multiply 4 with something, I'm going to get 12. What is that something? 12 divided by 4. Or that 4 will come down, isn't it? So I know it is 3. The same, logic here. The same rationale hold good here. So what do is, I have to keep x one side. Okay, keep x alone. Shift everything else. 25 is in the denominator, it will go up and become minus 20, plus 25. Okay, minus 25 divided by 5 as it is, don't touch it. It's in the left hand side, right hand side. Because whatever is with x, I want to find out x, whatever is along with x, let me take them to the other side. We'll keep x alone. We have to find out the value of x, so we have to keep x alone. So 25 goes up, and here 3 will come down. Okay, cross multiplication, 3 will come down. And now I'll show the working here. Minus 21 by 5 into 25 over 3. 3 ones are 3 sevens are 5 ones are 5 fives are. So it will be minus 35 by, because there is minus 21, so minus into plus, minus 35 by 1. Okay, so minus 21 by 5 into 25 will go up, 3 will come down, or it's simply minus 35. Okay, you can look at it in another way. 3 by 25 is multiplied with x to get what? Minus 21 by 5. Like 4 is multiplied with x to get 12. X will be 12 divided by 4. Same logic. Here x will be minus 21 by 5 divided by 3 by 5. Sorry, 3 by 25. 3 by 25 is the other number, isn't it? So just keep it this way. Division will change to multiplication. 25 will go up and 3 will come down. And the same logic. 3 cuts 1 time, 3 cuts 7 times. So minus 7 into 5 ones are 5 5, which is minus 35. And 35 by 1 or minus 35. So be careful when you incorporate this negative signs. Then if you have simplification problems, minus 3 over 13 into 12 over 40 into 26 over, let's say, 9. So if you have to have a, you have to make use of your tables, okay? So otherwise it will be very difficult, because if you don't know, now for example, given this sum, just change the color. Okay, without my knowledge of tables will be very difficult. 13 will cut how many times? 13 twos are. Then I have 3. And remember, there is a negative sign, so don't forget that. 3 ones are, 3 threes are. And let's see, 3 will cut 1 time, 3 will cut 4 times. So 2 will cut 1 time, 2 will cut 20 times. So again, 4 will cut once, 4 will cut 5 times, giving me minus 1 over 5. Okay. So you need to be very careful here, because in case while cancelling out, if I'm not going to do the right thing, okay, even if I don't know that 13 to the 26, or if I have 13 3 by mistake, then the entire cancellation, even one number is incorrectly cancelled out, that final result can go wrong. We'll check. The minus 3, we're not going to multiply. We're not going to multiply in the normal sense. What? Because you have to multiply the numerators divided by the denominators. Yeah. And you are supposed to get this answer. So minus 3 by 13 into 12 into 26 by 40 into 9. That is what it is, isn't it? When you have, multiplying 3 fractions, 3 rational numbers, you have to multiply numerators with denominators. But you will not simply be multiplying here. Even if you multiply, you will get the same answer. But the fact is here, you're trying to cancel out and simplify the process. So be very careful, because if you're getting sums like this, you need to keep your tables in mind. 3 cuts once, 3 cuts 3 times, 3 cuts once, 3 cuts 4 times, 4 ones are, 4 tens are, and then 13 ones are, 13 twos are. So you'll get 2 ones are, 2 fives are. See, I slightly changed the way I cancelled out the numbers, but it's going to be the same thing. Earlier it was 2 ones are, 2 20s are. Now it is 4 ones are, 4 tens are. So it doesn't matter. If you are good with your tables, you will know which two numbers are the common factors. And you cannot cancel 3 and 12, this 3 and this 12. I mean to say, you cannot cancel horizontally. You can only cancel out or cut out common factors. Cancelling means cutting out common factors only vertically or diagonally. Okay. So keep this in mind. The answer is minus 1 over 5. Okay. I think up till here, it's been helpful to you, the revision process. So it's just an additional practice for you because some of you asked me for revision. And please remember, children, that none of the questions will be the same. I've discussed few concepts here. I've discussed the working methodologies here. Yes, that's for your understanding. It is good that you work out and you understand along with your classwork and whatever we have done here. But the same numbers, please don't expect, okay? Because numbers will be changed. This is mathematics. So if you know the method, you can do the same. You can apply the logic to any other problem or any other combination of numbers, okay? So I'll come up with the next revision content in my next session, children. Okay, all the best.